Welcome to The Explainer. Today, we're diving straight into the mechanics of modern information. We're looking at how we take raw, totally chaotic data and, well, basically perform alchemy to transform it into serious predictive power and massive business value. Let's get right into it. To really understand why this is so critical right now, consider this wild stat. By 2025, the world is projected to generate a mind-blowing 175 zettabytes of data. That is an absolute explosion of digital information pouring in from every single online transaction and digital process out there. We are literally at a tipping point. We either drown in all this noise or we learn how to extract the actual truth from it. Okay, let's dive into this and align on what exactly these systems do. You hear these buzzwords all the time, right? Well, data science is the big, overarching, interdisciplinary field. It uses scientific methods to pull knowledge out of both structured and unstructured data. Machine learning, or ML, is the specific engine inside that broader field. It's a subset of AI where algorithms actually improve automatically through experience. They learn from the data to make decisions without you having to explicitly program every single step. So, why does all this matter? Well, mastering these disciplines is basically the ultimate superpower for value creation. We're talking way faster decision-making, highly optimized processes, and things like predictive maintenance in fields like electrical engineering. And because all of this translates to massive return on investment for companies, data science professionals are commanding incredibly high market value. To put that into perspective, average US salaries are sitting at nearly $138,000. Not too shabby, right? To actually capture that kind of value, organizations have to level up through what we call an analytics maturity curve. It starts off with descriptive analytics, which is just answering what happened. Then diagnostic analytics digs a bit deeper to figure out, okay, why did it happen? But the real magic, the real power, unlocks when you shift to foresight. Predictive analytics uses statistical models to forecast what will happen. And finally, at the very top, prescriptive analytics tells you, how can we make it happen or prevent it? You're moving from just reading the past to actively engineering the future. And this brilliantly illustrates the whole point. The key takeaway here is the relationship between difficulty and value. Look, moving from hindsight to foresight isn't easy. You're graduating from basic bar charts that show, say, a customer canceled their subscription to complex regression models that prescribe the exact intervention you need to keep them. The complexity definitely spikes, but the business impact skyrockets right along with it. So how do we actually pull this off in the real world? Enter the Data Science Project Lifecycle. This is a rigorous 6-phase framework, starting from defining your initial business case all the way through to deployment. It's the exact operational roadmap you need to handle complex data and reach reliable conclusions without just getting completely lost in the chaos. It all begins with discovery. That's sitting down with stakeholders to define what the actual problem is. But then we hit phase 2, data processing. And man, this is where the grueling work happens. This is widely considered the absolute most time-consuming phase of the entire life cycle. Your raw, chaotic material has to be meticulously scrubbed, mapped, and transformed to handle missing values and duplicates. Think about it. If this dataset isn't totally pristine, your final analytical results are completely compromised. Let's move to and see how this builds in the next phase. Once that raw data is finally filtered and structured, we cross a major threshold. We transition from preparing the data to actually feeding that pristine, clean information right into the machine learning brain for model planning and building. Now, model planning is highly strategic. Before you even write a line of code to build the model, you have to stop and ask, what specific insights are we actually trying to uncover here? Are we predicting categories, which is basically a classification problem? Are we forecasting continuous values using regression? Or are we hunting for anomalies and hidden structures in the data? The algorithm has to perfectly match the mission before you ever start training the system. Here is the hard truth, though. A fantastic model sitting in a vacuum is totally useless. All that process data and complex math literally only matters if it leads to real action. Phase 5 requires the true hero of this process, the data scientist, to translate their findings into compelling, easy-to-understand visuals for non-technical stakeholders. And finally, in deployment, you push that model out of the lab and integrate it directly into operational systems so it can drive real-world decisions. Successfully navigating this entire lifecycle requires a highly specialized hybrid toolkit. Yes, obviously, you absolutely need the technical horsepower. We're talking mathematics, statistics, and programming in languages like Python. But what truly separates a decent data scientist from a great one? It's the soft skills.
You need domain knowledge to understand the business context. You need top-notch communication to influence leaders. And you need this relentless curiosity to constantly ask the right questions.
Now, what's really interesting about this slide is that arguably the ultimate skill required isn't actually something you can code at all. It's just common sense. Amidst all the highly sophisticated algorithms and terabytes of processed data, human intuition remains totally irreplaceable. You always have to be able to step back, look at a model's output, and ask yourself, wait, does this actually make sense in the real world?
We currently have access to a more massive goldmine of data right now than at any other point in human history, and you've just seen the exact roadmap for how to extract its value. By blending these rigorous technical frameworks with human curiosity and a healthy dose of common sense, the possibilities for innovation are, quite literally, limitless. So the only question left for this explainer is, what will you build with it?